is just not enough. Or default subnet mask. And the subnet masks are designed to basically, as I mentioned earlier, to define the range or the domain within which two or more devices can actually talk to each other. So with that said, it means that when two devices are on different network IDs, they cannot talk. It just makes complete logic sense because they are two separate network domains. It's like having two people within two different regions. If you want them to talk, you have to basically, if you want to touch, if they want to meet up, you have to go through different roads. Or I'm using for a layman's interpretation point of view, assuming that you live in Tama and I live in Accra, and I want to visit you. I can't just maybe walk to Tama easily, even though you could, but it's too far of a distance. One, it's too risky. But within computer science, it's literally impossible because you're in two different regions or two different cities. So in order to allow you two to actually meet up, you'd have to find a way to transport you guys through a more secured and reliable medium. And that's where the subnet comes into play. So the subnet basically defines the domains for you guys, and with the help of a router, you're able to route each other's journey or routes of meeting each other to a destination where you can actually meet up. Okay, that's just me using for a layman's illustration. I don't know whether that helps you guys to get a picture or not. Within computer environments, they've basically placed all of the three classes that we use on regular network into their respective subnet mask. And that's, like I said, the subnet mask defines the domain in which two devices can talk. If two devices don't have the same subnet mask, chances are they can't talk. It means that they're probably going to have different network IDs. So there are limitations in terms of communication become very, very bigger without a router. Okay, so if they want to talk, they obviously need to route information across. So anyways, class A has got the default classes of subnet masks for the various class of IP that we have ranges from this way: 255.0.0.0 for class A, and 255.255.0.0 for class B, and 255.255.255.0 for class C. And if you notice, for class A, I said 255, meaning that we've occupied the first octet. And then we said 0.0.0. So there are 3 octets left, and that's where the small ants occupy. So the 0 represents the number of, octets that are available for what? For you to be able to assign devices with IP addresses. When it came to class B, it was 255.255, meaning that the first 2 octets have been maxed out, so you can use it. And it's been limited to what? Its network ID. But the subsequent 2 octets have 00. So that's what you have that you can assign. That's where the 16 bits comes into play. And then for class C, is just 255.255.255, letting you know that you've used up 3 of the 4 octets as what? Your network ID. And your only octet that you have to use for assignability is your last octet, which has got 8 bits. Hence the reason why it has the least amount of IP addresses. So if you do have a default subnet mask of an IP address, and you decide to basically reduce the number of nodes that it can actually lease out on a given network, you call that a subnet. So this is where the subnet IDs plays a key. So in this scenario, you have this IP address, which is what? A class B IP address with a subnet mask of 255.255, obviously, because the class B, the first two octets have been taken out. It's all maxed out. It's only the last two which are available. Okay, so this should have been 0.0, but it's been subnetted. And the reason why it was subnetted was because they don't want to waste the entire 16,000 IP addresses. They only want a few. So in this case, instead of having, so in this scenario here where you have a subnet of 255.255.240.0, instead of having a .0.0, you actually have a bit of the bits for the third octet being taken out as well. And if you were to basically put this into perspective, 240, okay, for you guys who didn't go through the IP address and its calculations, how you manipulate the bits, the zeros and ones to get your decimals or the conversions from binary to decimals or whatever, let me walk you guys through a bit so you can get a clear picture of what is going on within this scenario here that we have to represent your subnet IDs and your node IDs. Okay, so with that, I'm going to switch to my writing board so we can be able to get through some of these things here. I used to have a good Excel sheet for the guys from last semester. Yeah, I had an Excel sheet that we went through that showed you how you basically went about with the conversion. So you're able to easily identify your key conversion between binary and decimals. Okay, so we have oh, I'm not sure. Can you guys see the drawing screen? Oh, let me unmute you guys so you can talk a bit. Sorry, I have you guys on mute. So, okay, you can see it. Okay, good. Okay, that's great. So I'm gonna add one more thing. It's over here actually. This is it. This is what we're doing last semester before the semester ended. I'm load. So I'm using a writing pad over here. So this is what we're doing. Okay. So you have binary and decimals. And okay, I'm gonna post this video here, this material here on your YouTube channel. Yeah, it's already videoed, so I'm gonna basically post it on the YouTube video so you guys can go through. But with the scenario we have, you had an IP address of let me see if I can find over here. I think we did go through that. Okay, we didn't have that over here. We used different scenarios, different examples. Let me use the slide example instead. So one more tap. And then we had it was whatchamacallit, it was 255 .255.240.0, and this maxed out IP address tells you that it's uppercase N dot uppercase N, and these were supposed to be lowercase n and lowercase n. Okay, good. You can see that's good. So it did because you have these two maxed out with a 255, it tells you that's a class B IP subnet that you do have, class B. Okay, but this we're supposed to be, so this is your network IDs, and this were your nodes. Okay, this were your nodes where you can actually assign IP address. But you notice that it was supposed by default, you're supposed to have 255.255.0.0. But unfortunately, because of subnetting, like I said, to minimize the wastage of IP versions 4, they've basically taken up some of the full 8 bits that this guy was supposed to occupy. So now this is actually 240. 240 is decimal. IP addresses are in decimal. If you want to actually see it in its binary form, or the zeros and one, so you can understand how we got to the 240, then you need to break down this to its binary form. And it's 8 bits, so it's supposed to be 0, 0, 0, 0, 0, 0, 0, 0. That's 8 bits. But it's 240. All zeros are equals decimal of 0. So this is decimal, this is binary. Okay, binary, decimal. If it's all zeros, it's 0 decimal. But we have 240 decimal, so it's actually 240. Now the question is, how do we get the binary form? There's an easy approach to this. The first 4 bits on your left, from the leftmost, they carry the highest bits of binary and allocations. This is 2 raised to the power 7. This is 2 raised to the power 6. This is 2 raised to the power 5. This is 2 raised to the power 4. This is 2 raised to the power 3. 2 raised to the power 2. 2 raised to the power 1. And 2 raised to the power 0. So the first 4 bits carry the highest amount or the highest values. If you do the math, you can easily tell. 2 raised to the power 7 is 128. 2 raised to the power 6 is what? 64. 2 raised to the power 5 is 32. And 2 raised to the power 4 is what? 16. So they carry the highest bit in case they were switched to on state, if they were supposed to be in on state, which means they're all ones, then you'd have all of these values added up to give you a huge number. Okay, so 128 plus 64 is 192. Sorry, yeah, that's correct, 192, right? 192 plus 32 is what? Anybody? Oh, let me unmute you guys. Sorry, I kept saying unmute. I want you guys to participate so you can understand some of these things a lot easier. Unmute you guys so you can talk. Participants. Okay, now you guys can unmute yourselves. Okay, so 128 plus 64 is 192, right?
Yes, sir.
192 plus 32 is what?
224.
192 plus what? 32. 2, right? 2, right? 2, 2,
Yeah.
4. Someone said 214, wrong. So it's 2, 2, 4. Now that plus 16, you notice it will give you the 240, right? So that gives you 240. So that tells you the 240 actually, in binary terms, is 11110000. That is in binary. So 240 from decimal to binary is in 8-bit sequence. It's 11110000. Okay, so now keep this in mind. That tells you that always the first 4 bits from your right, from your left, will always add up to what? 240. Now let's pay attention to the last 4 bits. Like, if you were to change them to all ones, you will notice that 2 raised to the power 3 will be 8 here. To the power 2 will be 4 here. 2 raised to the power 1 will be 2 here. And 2 raised to the power 0 will be 1. And that will give you 15, right? That is if they were all ones. That is 15. So 15 plus 240 gives you what? The 255 maximum range of IP addresses that occupies your See that? Great. Okay, I'm going to feedback. So I'm going to meet you guys again. So continue. Okay, great. Yeah, I'll mute everybody so we can go ahead. So the 240 is actually what? 11110000. Okay, so if they took 4 bits out of the 8 bits, these 4 bits actually becomes what you term the subnet ID that we have. So these 4 bits have become the subnet ID. And now the rest will become the node ID now, because those are the assignable IP, bits left now that we can actually use for assignability, for assigned to devices. So we have, so basically we have 1, 2, 3, 4 plus the 8 from here. Keep in mind, this is decimal 0 here, which actually consists of what? 8 bits zeros in binary. So 8 plus 4 is what? 12. So technically, you have 12 bits that you can allocate as your words, nodes, or your node IDs. So if you want to know the number of IP addresses now that you can actually use that, you say 2 raised to the power 12, which is what? What's 2 raised to the power 12? Anybody? Anybody, guys? What is 2 raised to the power 12? It's 4096. 4096 IP addresses. But out of this 4096, it's only 4094 that can be allocated, because we say that there are 2 IP addresses that are non-assignable. Those are your network IDs and then your broadcast IDs, or your broadcast addresses and your network addresses. Those ones cannot be used. So in technical terms, the actual calculations is that out of the 40996, you have to minus 2, because the calculation is actually 2 raised to the power n minus 2 gives you your total number, the total nodes that can be assigned or is assignable. So total node assignable. So in this case, our small n was 12. So it was 2 raised to the power 12 minus 2. So this was 4094 now. Did you all get that? So this is the formula for calculating the number of assignable nodes IP addresses for a given subnetting question that you might have, what scenario you might have. It's always 2 raised to the number of nodes that you have that you're actually going to be using minus 2. And the 2 here represents the network address and then the broadcast address. And those 2 cannot be assigned to any device. So we take that out, and then you only have whatever it's left as your actual number of IP address that you can assign to any given device. So back to the PDF. Somebody says, is there another way to calculate for the bits? This is the main formula that everybody uses. That's been that they came up with. This is the only way. But the thing is, yeah, this is the formula they have. This bottom of the formula they have is 2 raised to the power n minus 2. For when it comes to calculations in terms of assignable IP addresses, it's always going to be 2 raised to the power n minus 2. But for just general IP addresses, to just know the number of IP addresses, you can ignore the minus 2 over there. So assuming a question, an exam or assessment, a quiz or whatever, and I ask you the total number of IP address, then you can just give me 2 raised to the power n, which is the 40996. But if I were to ask the number of IP address that can be assigned or the assignable IP addresses, then you know you have to minus the 2, because the total IP address also includes the network address and the broadcast IP address, which you cannot assign to any device. So you want to pay attention to the questions very, very well. However I frame it, you want to read and understand the key information that's being required from you before you try to answer the question. Okay? So for just total number of IP address, it will just be this. But total number of assignable IP address, you have to minus the 2. Okay, guys? Some of these things with time, once you keep practicing it, you start getting a pretty good idea of how it's arranged. So in this case, you notice that your network ID is actually the bits that were taken out of the 8 bits to be added to this in order to make it much better to not abuse the IP address that you have or limit the IP range that you do have. This will return your subnet ID. So there are ways to calculate this as well and ways to calculate this as well. We've already gone through this one. The same would apply to this one. So if you wanted to calculate, if we're given this one, assuming we're not given this, okay, you had the same scenario over here, the same subnet mask over here, and you are asked to calculate the subnet ID. Going back to the drawing board, if you go through this scenario, you will be able to tell easily what the subnet IDs will be, which in this case is actually 4 bits were used up. So in actual term, in terms of IP addresses, 2 raised to the power 4 were actually used for the subnet ID, which will give you what? 16, right? It's 2 times 2, which is 8. 8 times 2. Oh, this is going to be, sorry, this is going to be what? 16, 32, right? 32. Because it's 2 times 2, which is 4. 4 times 2. Sorry, okay, so that's right. 16, that's correct. It's 16, yes, not 32. That will be 2 raised to the power 5. So it's 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So in actuality, the subnet ID corresponds to a total subnet of what? 16 IP addresses that have been subnetted in order to basically minimize the number of wastages that we're going to have within that particular class B scenario that we have. So that's a good way to, that's another way to approach the question. But if I told you that you had 4 plus 8 or 12 bits, which is in this case 12 bits for the node ID, now calculate the number of subnet IDs. It's pretty simple. If the default subnet for class B uses up only the first two octets and leaves the last two, it means that you have 16 bits that you're supposed to be using. So anything other than 16 bits should be considered a subnet. So in this scenario where I give you 12 bits for the node, to get the actual number of subnet IDs, it's a matter of saying 16, which is supposed to be the default, minus the 12. So that gives you the 4. And the 4 is what you have right up here. So you can easily tell where the differences are. Sir, please, what if the IP address is more than 4? Example, you have 255.245.245.2. That is a wrong, that's a wrong subnet mask. You can't use a subnet mask like that. That's completely wrong. Let me go to his scenario here. Your scenario, you can't have a subnet mask like that. There are no subnet masks like this. Subnet masks are supposed to occupy, they start occupation from the leftmost bits. So in your scenario, you have 255.245.245, and then you also have the 248 and then the 0. You've even gone over the 4 octets. You have 5 octets now. You have 1, 2, 3, 4, 5. Have you seen it, Louis at Japan? You have gone over the maximum allocated for class for version 4. It's supposed to be 4 octets. You have 5 octets. So this is even wrong in the first place. Your example is wrong. We can't have this. So we can only have this. So it's not, this is 4. But even with this, since IP address occupy their bits from the leftmost angle, you cannot have a partial number of bits in the third octet, and then also a partial in the last octet. You're supposed to have exhausted this before you move to this. So in actuality, your ideal scenario should have been, no, that's still wrong. This should have been the correct way. It should have been 255.255.128. We've exhausted this now. You cannot have 2 unexhausted octets within a subnet mask. I think it's talking about, that's so wrong, no. So this is the correct format. You have to exhaust this before you move to here. So you can't have this not being exhausted and then move on to this. It doesn't work that way. For you to be able to use some bit of the last octet, this must be exhausted first. So like I said, the IP address gets exhausted in terms of the subnet mask from the leftmost. So if you notice, class A, we exhausted the first one. Class B, we exhausted the first 2. Class C, we had to exhaust the first 3. But here's a scenario that you give. You've not exhausted the first 3, but yes, so you're moving on to the last 3, the last octet. So this is wrong. This cannot form a subnet mask in any scenario. You have to exhaust this first before you move on to this. So what your scenario can be is, if you want to get this right, you can either have this one or have it this way: 255.245.245.0. Mean I have not exhausted this yet, so I can't move on to this. So these are the 2 options that you have. But this will be completely wrong.